Hello guys, welcome back to VC Tech. Have you ever wondered how large networks recover so fast when a link goes down? It's not magic, it's smart routing. In today's video, we are going to break down EIGRP, one of the fastest and most efficient routing protocol used in enterprise network. I will explain what it is, how it works, and why network engineers still rely on it till today. So with that being said, what is EIGRP? EIGRP stands for Enhanced Interior Gateway Routing Protocol. It is an advanced dynamic routing protocol developed by Cisco systems. It combines the feature of both distance vector and link states protocols. If you remember, we talked about distance vector when we were configuring RIP routing protocol, and we talked about link states protocol when we were configuring OSPF. Now you see, EIGRP combines both distance vector and link states protocol for speed and efficiency. Why is EIGRP important? One, it's fast convergence using dual algorithm, and incremental updates reduce bandwidth. It also supports VLSM and CIDR and loop-free routing, load balancing across unequal paths, and it is ideal for large networks. The key features of EIGRP is it uses dual algorithm for loop-free routing and partial and banded updates, meaning it sends only change routing information and only to the router that is affected. It does not flood the entire network with routing table, rather it sends only to the affected router. It also supports IPv4 and IPv6 and composite metrics based on bandwidth and delay. Now EIGRP table maintains three key tables. One, which is the neighbor table. It tracks directly connected routers, and the topology table that stores all the length routes, and lastly, routing table. It picks the best route using dual algorithm. So with that being said, guys, let's head over to the configuration phase where we can see how we can configure EIGRP on a router. Now for this tutorial, you can see we have 4 routers, 2 switches, and 4 host PCs that we are going to be using to test the network. Before we start configuring EIGRP on the routers, let's assign IP address to the interfaces on the router. As you can see, we have 6 networks for this topology, as we have 1 here, 2 here, 3 here, 4 here, 5, and 6 for this last local area network. We are going to configure EIGRP on all the router to enable its carry out routing protocol, and also enable this local area network to be able to communicate with this local area network. So before we get into that, let's assign IP address to all the interfaces on the router. Now I'm going to do that real quick, and I'm going to get back to you because I believe you know how to configure IP address to interfaces on the router. So interface gig 0/0 will be taking 192.168.1.1, which is a default gateway. And I'm going to move fast and configure the rest. I'll be back. Alright guys, so we've assigned IP address to all the interfaces on the router. Let's assign IP address to the host PCs, and let's try to ping and see if we are able to gain connectivity. For this device is going to be taking 1.5 with the default gateway 192.168.1. let's say 1.10 with a default gateway of 1.1. Let's also do the same for the second local area network. Assign IP address to this host PC. So this will be taking let's just paste that and change this to 2.10. Copy that, and default gateway of 2.1. So we've done this. Let's try to ping the default gateway of the other local area network, the 192.168.1.1. As you can see, guys, destination host is unreachable because we've not configured a routing protocol on the routers. Let's also check from this local area network. Let's try to ping. So one ping 192.168.2.1 local area network, and as you can also see, we are getting destination host unreachable because we've not configured a routing protocol on the routers. Now guys, let's head over to the router and configure a routing protocol so devices from each local area network could be able to communicate with one another. So we are going to be starting with this router over here and configure our routing protocol to the last router. So let's start. We say router EIGRP, and we want to assign an autonomous system number of 20. Then we also want to specify the networks. The network that are directly connected to that router is 192.168.1.0, and it also uses a wildcard bit of 0.0.0.255. Remember, we talked about this from the previous tutorial. And the second network of 10.10.10.0 with a wildcard bit of 0.0.0.255, and the last network of 128.64.1.0 0.0.0.255. Guys, we've configured EIGRP routing protocol on the first router. Let's also do the same configuration for the second router, the third router, and the fourth. Then we can test for communication. So for this router, we are going to do the same. So router EIGRP with an autonomous system number of 20. Guys, this is very important because this is how each router know that they are using the same routing protocol of EIGRP. If they have a different autonomous system number, let's say this has an autonomous system number of 10, it's not going to be able to connect with this first router that has an autonomous system number of 20. So we are going to be using ASN of 20 for this, and we are also going to specify the networks that are directly connected to it, which is 10.10.10.0 with the wildcard bit of 0.0.0.255. And as you can see, guys, it has immediately formed neighbor with this router over here. It has formed neighbor with the first router that we configured EIGRP on. Let's also specify the other networks, which is 20.20.20.20.0 with a wildcard bit of 0.0.0.255. And if you notice, guys, from the previous video, usually when we configure link state protocol, it takes 5 to 10 seconds for it to come on or for it to form neighbor, but for EIGRP it came up almost immediately. So that is how fast EIGRP is. Now for this router, it only has 2 networks that are connected to it. Let's also do the same for this router over here. Then we head over to the last router. So router EIGRP with an autonomous system number of 20. Remember, the autonomous system number are supposed to be the same across all the routers. Now we want to specify the networks that are directly connected, which is 128.64.1.0 with the wildcard bit of 0.0.0.255. And as you can also see, it has formed adjacency with this router over here. That is how fast EIGRP is. Let's also specify the second network, which is the second network, which is 128.64.2.0 with a wildcard bit of 0.0.0.255. Guys, we've configured EIGRP on the 3 routers. Let's try to ping from this router up until this router again and see what happens. And we'll also try to ping from this router to this routers over here that we've configured EIGRP. By default, this router is supposed to know the route. It's supposed to know how to get to this router and also this router. However, since we've not configured EIGRP on this router, it will not be able to locate or even ping any interface on the last router. So let's try to do that. Let's try to ping the default gateway of the local area network, and as you can see, we are getting destination host unreachable. Let's also wait for that to finish. Then let's try to ping 20.20.20.2. As you can see, guys, we are able to ping 20.20.2 because 20.2 is on this router, as you can see there, 20.20.20.2, and also 10.10.10.2. So it is able to work because we've configured EIGRP routing protocol on that router. Let's also try to ping this interface over here, so 1.2. So let's ping 128.64.2.2. We are also able to ping 2.2, and 2.2 is on this router, and we've already configured routing protocol on that router. Let's try to ping 2.1 from 128.64.2.1 and see what's going to happen. So 2.1. We won't be able to gain communication to that router since we've not configured routing protocol on that router to enable communication from this local area network to this router interface over here. So guys, let's configure EIGRP on the last router and let's try to ping. So we say router EIGRP with an autonomous system number of 20, and we also want to specify the networks that are directly connected, which is 192.168.2.0 with an autonomous system number of 0.0.255. And we also want to specify the second network. Remember, immediately we add the second network and the third network, we will just gain adjacency to the network since they are directly connected to that router. So for that, it's going to be taking 20.20.1, 20.20.1 with 20.20.0 with a wildcard bit of 0.0.0.255. And as you can see, immediately we form adjacency with the second router. Let's also configure for the last router, which is 128.64.2.1, 2.0, 0.0.0.255. And as you can see, we are able to form adjacency with this network over here and this network over here. So guys, let's try to ping the device that we tried to ping previously and we were unable to gain communication, which is the default gateway of the second local area network. As you can see, guys, we are able to ping the default gateway of the second local area network. So since we've configured the routing protocols on every router, and you're able to see that we are able to ping from one local area network to the other local area network, let's also check what routing protocol we are using, and let's also see the autonomous system number. So we can do that by saying do show IP protocol, And as you can see, guys, the routing protocol is EIGRP, and we have an autonomous system number of 20. So guys, this is how we configure EIGRP on a router, and we can also trace routes to see the routes that data is taken to get to its destination. So let's try to see from the second local area network, which is 192.168.2. Let's say 2.10. So as you can see, it left the default gateway of the local area network that we are using to ping the second local area network, and it went to 10.2. 10.2 should be on this interface right here, before it went to 20.1 and to the destination device that we were trying to ping. Now, if this video helped you understand how EIGRP is more efficient and fast compared to other routing protocol, then why not give me a like and subscribe to this channel, so whenever there is a new networking update or new networking video, you will be the first to know. Thank you guys, and see you in the next video.